In today's video, we're going to be writing decimals as fractions. So we're going to have two different scenarios, one with normal terminating decimals, and then we're going to have also decimals that repeat and go on forever and see what happens when we do both. All right, so for the ones that terminate, we have three different examples here. All right, let's start with this one right here. We have 0.4. So what I do is I write whatever's after the decimal, okay, 4, that's going to be in my numerator, okay? Now, being that there is only one number after the decimal point, okay? This one digit is after the decimal point. That means there's going to be 1 0 on the bottom. So just because there's one here, one digit there, 1 0 here, and it's 4/10. Okay, and then make sure you simplify. So 4/10, that reduces, right? You can divide them both. Change this color. You can divide the top by 2 and the bottom by 2, and you get 2/5. And that's my final answer. Okay. 4.321. Okay. Now this one has 3 digits after the decimal. So I need 3 zeros on the bottom. Okay. 1 out in front. And then 4, 3, 2, 1. Okay. Or you could do this and then reduce it. You could have the 4 out in front and make it into a mixed number. So if they want a mixed number, you leave it like that. If they want an improper fraction, okay, you would have to do 1,000 times 4 plus 321 is 4, 3, 2, 1 over 1,000. So depending on the scenario is what you're going, but depending on the scenario is, or depending on what they ask for is what you are going to put down. All right. So if they want this is called a mixed number. And this is called an improper fraction. Okay. So depending on what they're asking for, that's whatever form you're going to put it in. Okay. And then 0.55. So this one has 2 digits after the decimal. So that means there's going to be 2 zeros on the bottom. And then 55. And then we can reduce that, right? We can divide 55 divided by 5, 100 divided by 5. And you get 11/20. And I can't reduce that anymore. That's my final answer. Okay, so pretty straightforward when it comes to terminating decimals. Now let's look at repeating decimals that go on forever. So now we have 3 examples of repeating decimals that go on forever. 0.4 repeating, 0.36, 36, 36, 36, and then 1.033, 033, 033. So similar to the terminating decimals, the only difference here is I'm going to count how many numbers are repeating. So in this one, there's only 1 digit repeating. And the only difference is on the bottom, it's going to be, instead of a 0, it's going to be a 9. So 0.4 repeating is 4/9. Okay, you can't reduce that, so we leave it. All right. 0.36 repeating. There's 2 digits repeating here. So that means it's going to be over 9, 9. And then the top is going to be 3, 6. Now this you can simplify, right? Both are divisible by 3. And you get 12/33. I think you go even further with that. Yeah, you can. So now you can divide this by 3 again. And divide this by 3. And you get 4 over 11. Right? Okay. And a quicker way to do that, instead of dividing by 3 twice, you could have divided it by 9, right? 36 divided by 9 is 4, right? So if you would have, right from the beginning, divided by 9, right? This divided by 9, you would get 4 over 11. All right. And then the last one over here, I'm going to give myself some more room. I have 3 digits repeating, 033, 033, 033 again. So I'm not going to usually write, I don't need to write 033. I can just write 33. But how many digits are repeating? There are 3 digits repeating, so I have to put it over 999. Okay. Now I can reduce that, right? The top, again, divisible by 3. Bottom, divisible by 3. And you get 1. 33 divided by 3 is 11. 999 divided by 3 is 333. Okay. And I don't believe 11 goes into 333. Let me just double check. 333 divided by 11. Hit the wrong button. Of course. 333 divided by 11. Nope, it doesn't. So that would be my final answer. And if I wanted to write it as an improper fraction, right, 333 times 1 is 333, plus 11 is 344 over 333. So again, depending on the form of the fraction is what's going to be your answer. Okay? So that's it for today's video. Thank you for watching, and always remember, whether you're solving for X or Y, always give math a try.